Hello everybody, we are discussing today the concept of center of mass in physics. As you all know, in fact, center of mass is that point where the effective mass of the body that's going to act. For a circular lamina of uniform thickness, we will be finding the center of mass exactly coinciding with the geometric center of the body. Same is the case with a square. When we consider the square, the point of intersection of the diagonals, that itself is going to be the center of mass. Like that, of course, for every body, we people can calculate the position of center of mass depending on the shape of the body, the size of the body, and of course, sometimes the bodies are going to be in contact with each other. That time also, we can make use of some of the formulae to calculate the position of center of mass there. Let us discuss some of the questions based on different models of center of mass today. Let us say the very first question here, two spheres of masses 5 kg and 10 kg are connected from center of one to the center of the other by means of a weightless rod of length 1 meter. The distance to the center of mass of the system from the center of 5 kg sphere is. Generally, when we consider two bodies like this, the spheres which have been given over here, one is of mass 5 kg and one is of mass 10 kg. Both are directly connected by means of a rod, weightless rod it is. Its length is given a meter like this. If this is the center of mass of the system, if I consider the distance is x over here, this now becomes 1 minus x over here. With respect to center of mass, always it is understood m1 x1 must be equal to m2 x2. That is a condition for a point to be the center of mass of the effective system. So when we write like this, 5 times x is equal to 10 times 1 minus x. Simplifying this one, directly we will be getting here it is 5x and it is going to be 10 minus 10x. Total will be, x will now be 10 by 15. It's now going to be 2 by 3. 2 by 3 meter, the answer is going to be 2 for this. That is actually the concept based on which we can calculate the value or the position of center of mass there. That's the condition. Now let us take the second model, the second question what we people are having here. That is the one, the coordinates of center of mass of the system shown in the figure. Shown in the figure, of course, you people can understand there. 3 bodies are mentioned there. If you consider those 3 bodies, they are now given on the graph sheet. Like, of course, you people can find one body here. 1, 2 are the coordinates on y-axis and 1, 2 are the coordinates on x-axis. If you consider there is a body here, there is a body placed here, you can identify directly the coordinates here. For the first body, the coordinates are 0, 0. For this particular body, x coordinate will be 1 and y coordinate will be 2. For this particular body, x coordinate will be 2 and y coordinate will be 1. This mass is mentioned as 4 kg and this mass is mentioned as 8 kilogram. And what is the third mass over here? That is again 4 kilogram. In fact, we know the coordinates of center of mass. X coordinate of center of mass, when we write, it is m1 x1 plus x2 plus x3 plus, that is m3 x3 whole divided by m1 plus m2 plus m3. This is the formula. When we just consider m1 x1 will be 0, m2 x2 will be 8 ones 8 over here, m3 x3 will again be 8 divided by 4 plus 8 plus 4, that now becomes 12. It is 16 by 12 which now becomes 4 by 3. That now gives you the value of 1.334 by 3. That is actually the value of center of mass there. When once we consider the y coordinate over here, 4 times 0 once again plus 8 times 2 plus 4 times 1 divided by 16, that gives you y coordinate like. So by taking x coordinate and y coordinate, one can directly get the values over there, what exactly is the center of mass coordinates like. So this type of a question is a very commonly asked question, yet EAMCET and other model examinations like that. Let us consider the third question over here. we are having a different model here. 6 identical particles, each of mass m, are arranged at the corners of a regular hexagon of side length L. If the mass of one of the particles is doubled, then the shift in the center of mass would be how much? This type of a question can be taken up in a slightly different orientation. What for means we all can understand well, there is a hexagon taken over here, of which there are 6 bodies of identical masses which are placed over here. Their masses each are given as m. We people can understand, when we take the general center of mass is going to be the point of intersection of the diagonals. That is actually the concept. At the same time, when we take the length is L, distance to center of mass from every body also will be L only. Now the question is, when one of the masses is doubled, that is the question. When once we take up the center of mass concept, when we take up the formula like m1x1 is equal to m2x2, around 85 to 90% of problems of center of mass can be solved using this formula. That's a general formula, universal formula. Now in this particular case, what this m1 represents? m1 is the mass that is added in addition to the masses what are already present there. There are already 6 masses. One more mass is added over here. That mass is to be taken as m there. And what is the value of x1? x1 is the distance to the center of mass from that particular mass what has been taken out there. That is nothing other than L over here. Now m2. m2 represents the present mass of the system. Earlier there were only 6 masses. Now one more mass is added over there to that. Total mass will now become 7m over here. That into x2. This x2 itself is the shift produced in the center of mass there. If you cancel the value of m over there, you will be getting the value of x2 as L by 7. That is actually the value. L by 7 in the sense, the correct option for this one is going to be the third one. That is actually the way. m1x1 is equal to m2x2 is a very important formula for us while talking about center of mass of different bodies. Now let us consider the fourth. It's altogether a different model again. 2 bodies of mass is 6 kg and 4 kg have velocities 5i minus 2j plus 10k meter per second and 10i minus 2j plus 5k meter per second respectively. Velocity of center of mass of the system. The way in which we people is to calculate the coordinates of center of mass. For example, x coordinate if we want m1x1 plus m2x2 plus m3x3 and so on and so forth divided by m1 plus m2 plus m3 and so on, like that we people used to write. Exactly in the same manner y coordinate can be taken. In the same fashion we can take even z coordinate also. Exactly like that, when we want a center of mass's velocity, then we can write m1v1 plus m2v2 whole divided by m1 plus m2. This is actually the formula by means of which we can calculate the velocity of center of mass. In this particular case, m1 is given 6 into the value of velocity of that. It is 5i minus 2j plus 10k. That actually is the case. Plus, what is the second mass over here given? It's 4 into what is the particular velocity? It is 10i plus 2 minus 2j plus 5k. That actually is the case. Whole divided by m1 plus m2, that now becomes 10. Simplify this one directly. You will be getting here 6 into 5, it is 30i plus 40i. It is now going to be 70i. Likewise, minus 12j minus 8j, it's now going to be minus 20j. 6 into 10, 60k and plus 20k, it's now going to be 80k. Whole divided by 10, like if you write it, then 0 getting cancelled. 7i minus 2j plus 8k will now be the correct option over there. You will be getting 7i minus 2j plus 8k. This is actually the velocity of center of mass. Overall here, the answer is going to be the third option for us. That is the concept. In fact, you people should remember, light velocity, whatever we have discussed, even acceleration of center of mass also can be calculated using the same formula, m1a1 plus m2a2 and so on and so forth up to mnan divided by m1 plus m2 plus m3 and so on and so forth up to mn. That is actually the fourth question. Now, if you take up the fifth one, the center of mass of three particles of mass is 1 kg, 2 kg and 3 kg is at 2, 2, 2. The position at which a fourth mass of 4 kg to be placed in the system so that the new center of mass of the total system is at 0, 0, 0. That in the sense we can understand the effective center of mass now should lie right at the origin. That is the identification over here we have to have in memory. Now, if you take up the first concept, x coordinate is given as 2 here. But we know x coordinate of three body system, it is m1x1 plus m2x2 plus m3x3 whole divided by m1 plus m2 plus m3. This is actually given as 3, that is 2. Now, here what are the masses given? 1 kg, 2 kg, 3 kg. So, out of this one, you can now write m1x1 plus m2x2 plus m3x3. This is going to be equal to m1 plus m2 plus m3 being 6. 6 times 2, that becomes now 12. This is actually the formula 1. But he is talking about the fourth body of mass 4 kg which is to be placed at some other position so that the effective center of mass that should lie right at the origin, that is 0, 0, 0. So, if you take that fourth body, x coordinate which is supposed to be 0 there now becomes m1x1 plus m2x2 plus m3x3 plus m4x4 whole divided by m1 plus m2 plus m3 plus m4. This is supposed to be the formula for us. But we can all understand well, according to this particular equation, m1x1 plus m2x2 plus m3x3 already is taken up as 12. You can write that value here. If you just multiply this whole thing with 0, you will not be left anything towards left. It's understood now. 12 plus m4 being 4 into x4 must now be 0. Then what will be the value of x4 here? Exactly minus 3. When you are finding this x4 as minus 3, same way you can estimate what will be the y coordinate of the point. As the numbers are all similar and equal as well, you will be getting the y coordinate also minus 3, z coordinate also will be minus 3. Therefore, the correct option now becomes 1 in this particular case, minus 3, comma minus 3, comma minus 3. Those are the corresponding coordinates of that body. That is the point. Come on, let us go for the next number. This is actually a particular model which is based directly on purely a mathematical equation. In fact, we all know how to calculate the sum of all natural numbers, how to calculate the sum of squares of natural numbers. All these points are very, very common in mathematics. The same thing, of course, we people are applying for this particular question number 6. Particles of masses m, 2m, 3m and so on and so forth up to nm gram are placed on the same line at distances L, 2L, 3L and so on up to NL centimeter from a fixed point. Distance of center of mass of the particles from the fixed point in centimeter is how much is the question there. You can all understand, if I take a line like this, at every point we people are having a particular mass. This is m for example, this is 2m for example, this is 3m like that, this is nm like this. This is the order what has been given. From a particular point O, it is at a distance L, this is at a distance 2L, this is at a distance 3L and so on and so forth. These are the mentioned values. If at all you want the coordinate of center of mass, x coordinate is to be taken up as the bodies are taken up right along x-axis here. m1 x1, that is ml, m2 x2, 2m into 2l now becomes 2 square into ml. Third one, 3 square into ml, and so on and so forth, up to what? N square into ml whole divided by the masses m plus 2m plus 3m and so on and so forth up to n into m we can write it. So this is actually the formula. If you take ml as common over here, 1 square plus 2 square plus 3 square, like that you will be getting. That is the sum of all squares of natural numbers divided by m. If you take common, 1 plus 2 plus 3 and so on up to n, like we can write in the denominator. This of course gives you the sum of all natural numbers up to n. That is actually the concept. If you take up this equation, the very first one, what is the corresponding formula for this? ml into n plus 1 into 2n plus 1 whole divided by 6. This is the formula for sum of squares of natural numbers. What is for natural numbers over here? It is m into n plus 1 by 2. Now simplify this one, m gets cancelled, n gets cancelled, n plus 1 gets cancelled, 2 goes off here thrice. So what is left ultimately? It is now l into 2n plus 1 whole divided by this value of 3. This is actually the equation. L into 2n plus 1 by 3, that now is the position of the center of mass of the entire system of n different bodies having different masses. So this is a wonderful model over here. And the next one what we are having is the 7th question. Sometimes they used to ask you such type of a question based on center of mass as well. The concept is what here? There used to be a molecule like he used to mention. For example, in this particular question, potassium iodide, he is giving. What is the separation distance that has been mentioned? He is now asking you what is the distance to the center of mass from potassium, like he is asking. If you take the question, in equilibrium, potassium 39 is the mass number and iodine 127 is the mass number. Atoms of potassium iodide are separated by approximately a distance of 3 angstroms. The center of mass of potassium iodide from the potassium is how much? That is a question. Once again you can go ahead with the same old formula, m1x1 is equal to m2x2. In this case, m1 refers to the potassium, which of course is 39, and x1 we do not know, that we take it as x over here. What is the corresponding mass of the second element that has been given? It is 127. What is the separation distance given? That is 3 angstroms. 3 minus x will now be the remaining distance from the other element, that is iodine here. Now we just multiply this one, 39x is equal to 127 into 3 minus 127x. If you bring that one over here, 127 plus 39, it's going to be 6 here, 6 here, 166, x is equal to 127 into 3. If you simplify this equation directly, you will be getting the answer exactly as 2.29 angstroms. This actually is the corresponding distance from potassium. Same question you can be asked the other way as well. If suppose they ask you the question from iodine, what is the distance? You can take this particular x2 as x and this x1 you take that one as 3 minus x. That's the method of doing the problem over there. This is question number 7, right? Let us now take a very important model on center of mass, that is a question number 8 here. Sometimes that fellow used to say there is a square like this. This is a very commonly asked model. That square is made into 4 equal parts like this, and one part of this one is cut and being separated from the system. Then what would be the shift produced in the center of mass? That will be the question they ask you. From a square plate of uniform thickness and side length √2 meter, 1/4 of the plate is removed as indicated. the shift in the position of center of mass from the point O would be how much? O being the center of mass of the original piece. That's what has been mentioned there. But in this case also, our concept will not differ. M1x1 is equal to M2x2. This is the only formula. Once again I repeat here, M1 refers to the mass of that portion which has been cut, and x1 refers to the distance from this point to the center of mass of that cut portion of it, and m2 is the remaining mass, and x2 is the required value what the shift produced in the center of mass. As such, you can understand if the total mass is taken as m, this mass will be m by 4 and remaining mass will be 3m by 4. This 3m by 4 somewhere acts over here because the original center of mass was at O. Now it is being shifted to this particular point. That shift itself I just want in the form of x. So if you take m1, which is the mass of the cut portion, into what is this distance to the center of mass from the original piece, you can understand this way. Root 2 is this value, root 2 is this value given, then what will be the diagonal? Diagonal becomes 2 meter, and you can understand this now is going to be 1 by 2 meter as such. So what will be the distance over here? Half meter. That now is going to be 3m by 4, that is the amount that is left over there after this has been removed from the system. M by 2 gets cancelled, then x2 will be how much now? 1 by 6 meter. So 1 by 6 meter is the shift produced in the center of mass of the system, as and when we just cut this one and remove. This type of a model can be asked by taking circular plate, by taking spherical bodies, and so on and so forth. So option in this particular case is the third one, that is the correct option there. Let us now go to the next number, which is question number 9 there. If you consider that two circular plates of radii 8 cm and 6 cm are cut from a uniform metal sheet, that itself is a very clear indication that thickness of each plate is going to be the same. They are placed side by side, touching each other. The position of center of mass of the system from the center of the larger disc is how much? One is of 8 cm radius and the other one is of 6 cm radius. Both are touching each other is the question. But in this case, cleverly that fellow has not mentioned what are their masses. But one thing we can all understand, mass of course is going to be volume into density. That is the basic equation which all of us we know. Volume in turn for a circular disc is directly proportional to the radius, because volume is pi r square L into density becomes rho. Out of that, r is the only variable. Once again we people have to go for the same old formula. M1x1 is equal to M2x2. Now here M1 stands for the mass of the first body. First body's mass is proportional to its radius square. What is radius given here? 8. 8 square will now be 64. What is the distance to the center of mass? I do not in fact know. I take that distance as x. Then what will be the remaining distance here? It will now be 14 minus x, because the total distance of separation being 6 plus 8, 14 centimeter. 14 minus x will now be the distance there. So 64 into x must be equal to 6 square, which is 36, into 14 minus x. That is the concept. 64x minus this plus 36x, how much it will now be? 100x is going to be 36 into 14. That is the point. You will be getting x value exactly 5.04. That is actually the concept what you people have to take up. So it is actually supposed to be centimeter. By mistake it has been given meter there. So remember all of you, it's 5.04 centimeter, because all these numbers are given in centimeter there. The value is going to be 5.04 centimeter only. So this is one more model. Now let us go to the next number. The mass of a uniform ladder of length 5 meter is 20 kg. A person of mass 60 kg stand on the ladder at a height of 2 meter from the bottom. The position of center of mass of the ladder and mass from the bottom. The moment you can understand that a person is standing on a ladder like, and we people are considering the distance to center of mass from one end. So directly you can remember this formula like the formula for x coordinate. It is m1 x1 plus m2 x2 whole divided by m1 plus m2. Same formula even can be applied over here also. m1 being the mass of the ladder and x1 is going to be the position where exactly that mass is going to act. He is talking of mass of the ladder as 20 kg and length is going to be given 5 meter. Then where will the total center of mass of the ladder that lie? It lies exactly at 2.5 meter from the bottom or from the top. So we can understand m1 in this particular case is 20 into what is the value of x1 over here? It is 2.5 plus what is the mass of the personality given? That is 60 into at what height he is standing? At 2 meter height he is standing divided by the total mass now becomes 80. Now you will be getting here 20 times 2.5 will now be 5. This is 120 by 80. 125 by 80. Whatever the value you people are getting here, right, you can directly take this one. It is 60 into the value of 2 meter from the bottom. Everything of course he has given very clearly there. So whatever be the value after simplification you will be getting, right, you will be getting this one is 0 if it cancels, it is 50. So it will be 170 by 80. So you will be getting definitely near around 2 meters like something like you will be getting. That is actually the concept what is to be taken up. So that is one of the questions where we can go ahead with the same old formula like that. Come on, take up the next one. From a sphere of radius 1 meter, a sphere of radius 0.5 meter is removed from the edge. This is similar to the earlier model what we have taken up. From a square, a small square has been cut. Likewise, from a sphere, a small sphere is supposed to be cut like this. That is a point. Once again, we people have to go for m1 x1 is equal to m2 x2. That is the only formula for all these models. What is m1 here? Mass of that cut portion what has been given. What is the radius of that cut portion? 0.5 meter. So you can all understand mass in this particular case is 4 by 3 pi r cube into rho. Volume into density, that is the formula corresponding. That's naturally m is proportional to r cube we people can take up. Then what is radius given? It's 0.5 meter that is given. Therefore, here I can write r1 cube into x1 is equal to, what is this one now? r2 cube into x2. What is this r1 cube? That is 1 by 0.5 means half whole cube. Into at what distance that is located. He is just talking about the radius is 0.5 meter. Earlier was the radius was 1 meter. This is only 0.5 meter. So the distance to that center of mass is going to be 0.5 meter as such is equal to what will be this R2. This is in fact M2 means the remaining mass we people have to take up. This now should be taken 1 cube minus half cube over here. Total mass minus this portion's mass will give you the mass of the remaining. So this into the value of x2. You can understand 1 minus 1 by 8 here. This is 1 by 2 whole cube 1 by 8 here. Directly whatever the value of x2 if you calculate, you will be getting exactly 1 by 14 for that. So that is actually the concept you have to understand. That gives you the option number 4 over here. That is a question number 11. So this equation is most important out of all the equations whatever we have in center of mass. Now come down to the next question over here. A boy of mass 50 kg is standing at one end of a boat of length 9 meter and mass 400 kg. If he runs to the other end, the shift produced in the center of mass of the boat boy system will now be how much? Now in these models, one more point you have to understand. Center of mass does not depend on the internal forces which are acting on the system. Internal forces will never change the center of mass. For example, when I lift my hand up, my center of mass is not going to be changed there. When I pull my hairs like that, my center of mass will not be changed there. Exactly in the same manner here, the person whosoever is running on the boat there, that fellow's internal force only is acting on that. He is not acted upon by any external force over there. Therefore, center of mass of the boat buoy system will never have any sort of a change in its position as such. Therefore, what would be the shift produced is the question. Since there is no shift that is produced, you can understand center of mass shift will be 0. That means the very first option. Such questions should not be worked out. Only thing is, you people should understand straight away what is the corresponding theory behind that. Center of mass does not vary with internal forces acting on the system. That is a concept you need to know. Now let us take the next number, that is 13. Two spheres of masses m and 2m are initially at rest at a distance r apart. Due to mutual force of attraction, they approach each other. When they are at a separation of r by 2, the acceleration of center of mass. Once again, just look at this one carefully. There is a sphere here, there is a sphere here. Its mass is m1, its mass is m2. They are now being attracted. Attracted by what? Mutual force of attraction. Mutual force of attraction comes directly under internal force itself. Internal force will never change the position of center of mass. When you know that system carefully, you can understand when the system is having internal forces between them, there is no change in the shift in the center of mass, no velocity you will have for the center of mass, no acceleration also you will be finding for the center of mass. Therefore, what must be the answer again? Again it is going to be 0, because acceleration of center of mass comes only into picture when center of mass is changing from its position. Since it is not changing here, acceleration becomes 0. That is a concept you have to understand from this question number 13. Now come to the 14th one, please. A dog weighing 5 kg is standing on a flat boat so that it is 10 meters from the bank. It walks 4 meters on the boat towards the bank and then halts. The boat weighs 20 kg and one can assume that there is no friction between the boat and water. The distance to the dog from the bank at the end of this time is a wonderful model once again. This does not come under this center of mass, rather internal forces, because he is not asking you what is the shift produced in center of mass, how much distance this boat goes back, he is asking. So if you take this is the boat and this is the position of the dog, what we people are talking about. That dog of course is at a distance, according to the given problem, 10 meters from the bank like. That is the one. Now it is moving here by 4 meters. What is the mass of the dog that is given? It is given 5 kg. What is the boat's mass is that's given? 20 kg. Now first of all you identify by what distance this boat goes back. For example, if you take 5 into the distance travelled by the dog is equal to dog plus boat 25 into the distance moved by the boat backward. You can write x is equal to 20 by 25, which now becomes 4 by 5, that is 0.8 meter. Now you can all understand this is the present position of the dog. But the boat is going back by 0.8 meter. Earlier it was at 10 meter, now it is at 6 meter, you can understand, but the boat is going back by 0.8 meter. So what will be the total distance to the dog now? 6 plus 0.8, now that becomes 6.8 meter from the shore. I think the concept is clear to you all. This has come down by 4 meter, actual distance is 6, but this boat is going back by 4.8 meter, so total value will now be 6.8 meter. So option is going to be the second one for that. Coming to the next question over here, one of the excellent models what we people are having in center of mass once again. If you take the two masses m1 and m2, m1 is given greater than m2, are connected to the ends of a light inextensible string which passes over the surface of a smooth fixed pulley. If the system is released from rest, the acceleration of the center of mass of the system will be g is acceleration due to gravity. You can understand this being the pulley. A body of mass m2 is here. A body of mass m1 is connected over here, and it is given that m1 is greater than m2. That means m1 accelerates downwards, m2 accelerates upwards. What is the formula for its acceleration? First of all, it is the difference of their masses by sum of the masses into acceleration due to gravity. This is the formula for acceleration of the body. But we can understand one point, this being accelerating downward, the other one being accelerated upward, but both are going to have the same acceleration as such. Now his question is, what is the acceleration of center of mass? You can write m1a1 plus m2a2 divided by m1 plus m2. That is actually the formula. But be careful here. You are finding that one body is coming down, other one is going up. Therefore, its directional value is to be taken reversed. That means we have to write with a negative sign. Now, what is m1a1? m1 into m1 minus m2 by m1 plus m2 into g minus m2a2. m2 into m1 minus m2 by m1 plus m2 into g whole divided by m1 plus m2. If you simplify this one, you will be getting m1 minus m2 whole square in the numerator, m1 plus m2 whole square in the denominator. Therefore, m1 minus m2 by m1 plus m2 whole square into g, that is the corresponding acceleration. You will be finding the same option as the second option over there. So this is the formula for acceleration of center of mass there. So this is the question. Now come to the next one. Two particles of masses 1 kg and 3 kg have position vectors 2i plus 3j plus 4k and minus 2i plus 3j minus 4k respectively. The position vector of center of mass of the system is how much? Once again, position vector, whether they ask, or acceleration they ask, or velocity they ask, ultimately the formula will be the same. m1 r1 plus m2 r2 by m1 plus m2. r1 is the first vector, r2 the second vector. Now if you look at one time the value of 2i plus 3j, of course the other one plus 4k, that actually the value, plus what is the next one? You are having the second mass, that is how much? It's given 3 kg into the value of r2 is how much? Minus 2i plus 3j plus 4k, that is the second one, whole divided by m1 plus m2, that now becomes 4. If you look at here 2i minus 6i, it now becomes minus 4i. 3j plus 9j, it now becomes 3 plus 9, it's now going to be 12j like. Now next one, 4k plus 12k, it's now going to be 16k whole divided by 4. Then what will you get out of this one? Minus I plus 3j plus 4k. This is actually the concept. Actually, it's given slightly differently here. The second option is supposed to be the correct, and it is now supposed to be plus 4k. It's not supposed to be minus 2k as such. That is a concept what you have to take up. This is the model. This is the method you people have to adopt there. That is the concept there. Now come to the next concept there, please. A circular disk of radius r is removed from a bigger circular disk of radius 2r such that the circumferences of the disks touch each other. The center of mass of the new disk is at a distance nr from the center of the bigger disk. Now the value of n is how much? That is the concept. Once again, as I have already given you two models earlier, you can directly go for m1x1 is equal to m2x2. That is a corresponding value over here you have to take. Out of that, this is a disk once again. Disk means mass is proportional to square of the radius. Then m1 is to be taken, it is proportional to r square like. And what about m2? m2 is the mass of the remaining disk. Remaining disk means how to write that one? 2r whole square minus r square. It is now going to be 3r square. Now of course you people can straight away understand, from a bigger disk of radius 2r, a smaller disk of radius r is cut. Then r becomes x1. And what is the value of shift produced? If I consider that shift produced as x, that is now to be calculated. So what will be the value of m1 x1 over here? It is r square into r. R square in terms of, in place of m1, x1 is going to be the center of mass distance, that is r, is equal to 3r square into the value of x. you can directly cut these two r square values. You need not even substitute the values there. X now becomes r by 3. The correct option for this one is now going to be 1/3 of r. N times r it is given. Therefore, n becomes 1 by 3 into r. What is n value? The question. It now becomes 1 by 3. That is actually the concept. You have to understand. Now come to the next one, that is problem 18. Two particles of masses 2 kg and 3 kg are at a distance 5 meter apart. If half of the mass of the lighter particle is removed from it and added to the heavier mass, the shift in the center of mass. Once again, if you go ahead with this, 2 kg and 3 kg are 5 meter apart. First of all, this is 2 kilogram, this is 3 kilogram. 5 meter is the distance of separation. Let us take this point is the center of mass, this distance being x there, then the remaining will be 5 minus x over here. Now let us take 2 times x must be equal to 3 times 5 minus x. You can write 2x is equal to 15 minus 3x, 5x is equal to 15, or x is going to be 3 meter as such, that actual distance to the center of mass. Then what is he talking about? Half of the mass of the lighter particle. Lighter particle is 2 kg. Now half of that one means 1 kg. That is added to the second one. Then what would be the system now? This will be only 1 kilogram. This now will be 4 kilogram, and the total distance of separation remains as it is. That will be 5 meter only. Now what is the distance to the center of mass? Let us take this one as x1 again this time. x1 is equal to 4 by 4 plus 1 5 into 5. 5 getting cancelled. 4 meter you people are getting. Earlier it was at 3 meter distance, now it is at 4 meter distance. What is the shift is the question. It must be 4 minus 3, that now becomes 1 meter as such. That means the option is correct option, that's going to be 3. That is the concept you have to understand. Now come to the next question over here, which is a figure oriented problem, where of course that fellow is giving us few bodies are placed one over the other, 4 identical planks each of length L are arranged one above the other over a table as shown. Each one projects a distance a beyond the edge of the other one, that is below it. The maximum possible value of A for the system to be in equilibrium without tripping forward would be. Generally, when we people are making the bodies placed one over the other this way, there is a possibility for us to find the system will trip. But in this particular case, this is A, this is A, this is A. What exactly is the distance maximum projection of A? That's what actually he is talking about. So if you talk about this one, generally the center of mass lies at half the length, that is L by 2. So what is the distance to the second body over here? If I take x coordinate, it can be taken m1 x1 plus m2 x2 plus m3 x3 whole divided by m1 plus m2 plus m3. This is the general formula we people used to take up. When you take this particular equation, you will be finding that m1 is the mass over here. All are identical. So I can take the same mass m. But x1 in this particular case is L by 2 plus A. Half the length plus A. If I take the second one, it will be L by 2 plus 2A. Because this is A and that one is A again. If you take with respect to the same point, x3, L by 2 plus 3A, 4A, 5A, and so on and so forth, like that we will be having. Then how to write the corresponding value for x coordinate? It is m into x1 means L by 2 plus A plus m into L by 2 plus 2A plus m into L by 2 plus 3A. Likewise, whole divided by m1 plus m2 plus m3, that now becomes 3m over here. But one thing you have to understand, what will be the maximum projection you can have? You cannot cross the total length of each plank there. So this must now be maximum of L. That is the point you people have to understand. The moment it is equivalent to L, then what can we write now? cut this mass over here throughout. If you take m common and cut that one, you will be getting 3L by 2, L by 2 plus L by 2 plus L by 2, that now becomes 3L by 2, plus this is A, 2A, 3A, total 6A is equal to 3L. Now 6A is equal to how much? 6L minus 3L, that is going to be 3L. So A will be how much? 3L by 6, which now becomes L by 2 over there. L by, just 1 second, the value over here, this is A plus 2A plus 3A, that you will be getting 6A, and of course this M, if you take that one common, by 3M, like, of course we are having there 4 different masses, that of course is to be taken as 4M here. Then what will be the value here? 4L this now becomes. So this now becomes 6L, 1 second, this is 4L, right? 6A is equal to 8L minus 3L, that is actually the case you have to take, right? That is 5L. You will be getting the value of A, that is 6A, that is A is equal to L by 4, that is the value what you will be getting directly if you calculate. L by 4, in the sense the correct answer for that one is going to be the second one. You remember that equation therefore. Now come to the next one, that is the last in this particular order. That is another model here we are having, that is center of mass, the last question. On a large tray of mass capital M, an ice cube of mass small m and edge L is kept. If ice melts completely, the center of mass of the system comes down by what extent? In fact, we all know this is the ice cube. Usually the center of mass lies at L by 2 distance. We know that. Now it is melting, means center of mass will certainly come down. By what extent it is coming down is the question. So if you take up this value, the mass of this ice tray that has been given as capital M, and mass of this ice cube that has been given as small m, and length is L, means L by 2 will be the value. Now what is this x coordinate? Similar formula is to be taken up for this one also. What is that formula here? You can understand that the total mass, that is small m, has got L by 2 as its distance to the center of mass, right? Plus what is the other one over here? That is m plus m, right? That into what is the value of x we have to take up. That means what you find here, the value of m into L by 2 must be equal to m plus m into x. That means what? m1 x1 is equal to m2 x2, the formula. So you can now write this m plus m into x. What will be the corresponding value there? You can get x as m into L by 2 into m plus m. This particular value you will be getting ml by 2 into m plus m, which of course coincides with the very first option there. So this is one of the excellent questions which has been asked earlier in one of the EAMCET examinations also long back. So that is one more area you people have to take. Overall, in center of mass, there is only one concept one has to remember. m1 x1 is equal to m2 x2. That's a very commonly asked model. That is a very important formula there. Cutting the bodies from a part of that one, what is the shift in the shift produced in center of mass, they may ask you. Like that in different orientations, like giving different masses, what exactly is the position of center of mass of the system, like they may ask you. These are the very important models, and at EAMCET level we always used to get one question surely from center of mass, and in my opinion, if you are a little careful in calculating things and all carefully, certainly every one of you can score that 1 mark as far as center of mass that is concerned. Later on, of course, from means next day we are going to take up one more chapter, like that is on friction. That is one of the concepts whatever we are having like.